But yeah, hi guys, my name's Ivan Lugo. I've been doing Android dev for about 3 years now. Senior position for about a year now. And I jumped very quickly from a more junior. I had to kind of fill some big shoes in terms of requirements and understanding how to build an app and business responsibilities. One of those requirements is, hey, you have to understand the tools you use to solve the problems you have for the business. So in my time of doing my development, I've been trying to understand, well, if I'm going to accelerate, I'm going to learn, I have to challenge myself and learn new tools. And so one of the things that happened, I'm sure everyone heard, when Google gave their thumbs up to Kotlin and said, hey, this is a first-class language, I think to myself, hey, look, this is a new tool. It seems to be great. I've heard it from a number of people, especially here in the Orlando meetup, that it's a great language with great tools. So I started doing a little digging. And while digging, I actually came across this guy, Andrei Braislav. He was the development lead for Kotlin way back in 2011. This is not that new a language. It's been developed for a long time. It's rather mature. And in looking for kind of what Kotlin was about and what it did, I came across a really awesome quote from Rebel Labs did an interview. And it's kind of a longer quote, but the heart of this is that it really hits every single responsibility that I had to take care of in my business's application, and also kind of hit me as developers. And the big things are really, hey, you can mix Java in this new language. It's interoperable. You guys are actually caring about not just kind of writing good code, but also capturing your intent as a developer. You're going to hear me say that a couple times during the talk, and as well as the idol. If you know Mr. Uncle Bob in his talks, you'll have heard the word intent quite a lot as well. So let's talk about architecture in Android and intent in Android, right? So what problems are we trying to solve in Android, right? What kind of problems do I have, and what kind of problems do you guys have? Really, you're kind of in a really volatile environment, right? You really are. You have a user interface that can kind of live and die by the sword of the user. And that's to be expected in really mobile environment in general. But it's a little, as an Android, you kind of understand, we talk about lifecycle, this one thing. So UI components are things like nullable. System services may not be around when you expect them, and you have to handle those cases across devices, across API versions. As I said, not only you're a volatile, but you're a mobile one. So not only are you doing kind of back-end work to manipulate data and pull stuff, but you also have to present that to the user. What happens when a REST call fails? What happens when data is not available or something fails in some way you don't expect it, and that string you're going to display for the user's name is null? We don't want a null pointer exception, right? But that's what you have to deal with. And one thing that I particularly had to deal with, what I imagine a lot of Android developers have, is you also have a legacy environment. You have lots of older API versions to deal with, as well as probably old code if you've inherited it, either from a senior dev like I had to kind of jump into, or if you were like a lot of other people too, who had to take one version like an iOS app and move it over Android. So you have all these large swaths of code you have to kind of make compatible and deal with it. And it's not quite as easy with languages like Java, where you have lots of verbosity and lots of types and lots of checking, lots of tools, but it kind of misses in some key things. So what you really come to find out is that you really need good tools for hard problems, right? So what I'm going to do is talk about Kotlin with a couple key things that I really liked, starting in the language. And again, this is a very brief overview. I've only played with some kind of the tip of the iceberg, if you will, powers of the language. But I'm going to start first with data classes and type nullability. You probably heard of this a little bit, maybe in the Google I/O talks and how they're talking about data classes, what the differences are. I'll talk a little bit about extensions and kind of how I use them in a sample app as well. And then I'll talk about lambdas, which I'm sure everyone's heard about and talked about, and kind of what they can be used for. And I'll kind of give you one or two side comparisons with Java and the difference, right? So let's start with data classes and a little bit of syntax. So if this is your first time looking at Kotlin code at all, this is a data class. So a data class is a class that houses data, and that's really all it is. So the point of a data class in Kotlin is to encapsulate just your strings, just your text, things that are data and nothing else. And Kotlin kind of rewards you for that by giving you a lot of little freebies, which we'll see in a second. So the first line you see on here is the declaration, right? I have a data class and it's called object recording. But notice that I've got some open parentheses rather than curly braces. And now I'm defining some variables. I have a value, which is the equivalent of a final variable in Java, if you think about that, right? I also have a var, which is a non-final variable. But you'll notice right next to that, I also have a little bit of a string in there. It's called a default value. So what I'm going through is I'm defining a class that has a non-changing ID, which kind of makes sense for something, right? If you want to change your ID, make it constant. Maybe the name you can change. So I'll default that to untitled for something like an on-disk recording. But now I've got one more variable in there that's a list of strings. And notice that nice little guy down there, that red question mark. That's part of Kotlin's type nullability. You'll see that in action right now, actually. So let's take a quick look at actually using this data class. Okay. So you'll see that I'm defining a function here, and the name is test. And Kotlin, like if you're experienced with Objective-C, has named parameters. So I can say, hey, look, this is the name of my data class, which is on-disk recording there. And you can call that method. You can do whatever you want with it, just like in Java. And we'll also see some more advanced uses of calling methods in a few slides as well. So I'm declaring this. The colon and the on-disk recording means that, hey, this method is supposed to return an on-disk recording as well. So I'm moving to the next one. Now, this is the first really cool thing to get with data classes. Data classes give you three freebie functions that I can recall, but I believe there are a couple other. You'll have to look that up yourself. But there's copy, inherent in data classes. There is equals inherent in data classes, and there's hash code. So if you have a data class, thing like an on-disk recording, you don't want to have to write all three of those things for every single bit of data you have, right? In general, if you have some data, it should probably be equal to itself based on its parameters. And that kind of makes sense, right? Unless you have something very, very tricky, like maybe it's a view model that has some very tricky differences with how to check one change to the other, you want to keep your data equal on some very basic parameters. So one of these things you have here is copy. And copy literally just takes your primitives and makes a deep copy of that object and returns it to you. That's it. You didn't have to write any code, you don't have to do anything special, it just gives you a new version of that object. But you can also use name parameters while making the copy to influence what the variables are for that object. So here I have a value, so it's not changing. It's a copy of that on-disk recording that I've passed in. And that on-disk recording, I want to change or I want to make a new on-disk recording with an ID. Maybe a persistent, this is some database now it has like a true persistent GUID. And I also want to give it a list of tags. So now it's there. So I've now copied a data model, let's say with whatever the user named it, okay? You get equals for free as a part of the data classes, but notice the magic there with the double equal sign. You don't have to call dot equals on this. Kotlin also has operator overriding. Now, I wouldn't jump right into that because you can do some pretty crazy things with overriding like pluses and minuses and adds, right? But when it comes to understanding, hey, I don't want to have to think about like equals versus dot equals with undercase, but sometimes not. It's a little silly, right? I have data. I want it to be equal. Please deal with that, right? And that's the kind of theme in Kotlin. So this will be false because obviously these data objects are not the same anymore. I've changed the ID and changed the list of tags. In this last one, there's a couple of things in here that I really like. The first one I'm going to point out is this dot apply. So there are lots of little helper functions in Kotlin, tons. They're collections classes, how they deal with streaming data, and one of this is apply. And I'll say it once, and I'll take plenty of questions if you haven't, but the idea is you apply onto an object some function, right? And you see these two curly braces here. And when you say apply, that object becomes the scope, the context of what you want to do. So in the next line, I'm saying, hey, look, name, which is actually the name of the data model at the top there, gets some data, dot, and then tags. And I'm accessing an array of tags. But there are two awesome features here. The first one is the null accessor, whose name has now escaped me, unfortunately, question mark dot, and the second one is colloquially called the Elvis operator. But there are two things happening. The first thing is I'm saying some data dot tags. Now you remember that in the data model, I put a question mark after the list of strings. And what that meant is this may be null. That's it. That's all you have to do to declare something can be null. But when you do that, Kotlin is going to force you to interact with that object and recognize the fact that you told it was null. So you actually cannot, it will not compile if you do something like some data dot tags and then did something with that. Because what you haven't done is told the compiler that I've dealt with a situation that it can be null. Instead, what you say is question mark dot, and now at runtime, what will be compiled at the bytecode level is a series of checks as deep into this nested call stack as you want, where where these objects are checked for nulls. And at any point during that call stack, if I had some data dot tags and then 30 extra dot question marks at the end, if any of those result in a null value, the entire expression quits immediately. It returns null. The end. No questions asked. No, if this is null, no, it's just done for you. Then the next part works really well with that, which is the question mark colon. That's the Elvis operator. What that says is, if anything on the left, if an expression, which is this class, which is this right here, ever evaluates to null, I want you to return this object instead, or really to apply this expression. So what this apply is saying is, hey, look, that little bit of data that I copied, I want you to apply it a new name, which is the first tag if it's not null. But if it is, just say the name's no tags. And that's it. With basically 2 lines, 3 if you want to count the curly brace, I've modified an object, checked all my nulls, and then returned it. That's some pretty cool stuff, right? So I'm going to do a quick comparison. Here's our data class in Kotlin, and here's the beginning of the class in Java. So I've got some private variables, and oh man, it jumped a little too far ahead. Hopefully I can get back a little bit. Excellent. So got the class declared here. Private final string, that's my equivalent of a val, right? I'm already kind of adding some verbosity, but this is just a declaration of the object. This is just making sure you can't mess it up. If I skip on to the next one, you see the next one, which is a custom thing, and now I have a bunch of getters and setters, and I'm kind of haphazardly applying nullable tags to make sure you understand that this thing can be null, but you have to deal with that. And at the end of this, after all of my setters and getters, I still have to do my copy equals hash code nonsense. And that is kind of painful. I don't want to have to do that, especially if I do something, say, like change the data model. That would just be too much, right? So that's some very basic syntax and nullability and data classes in Kotlin. And now we'll kind of use it in the next slide, which is extensions. So an extension can be thought of as a simplified static method that you can call on object instances. It's a little weird, but I'll point this out. So you notice that I have a data class, right? Or have a class, not a data class, which is an on-disk recording. And I'm declaring a function again, which says as audio file. Now what this does is anywhere else in this class file, or this Kotlin file that I've constructed, I can call on instances of this on-disk recording as audio file, and it will actually execute that code as the object, which is actually really cool. Because you can do things like, hey, you know what? I want to see whether or not this recording exists. But I don't want to have to always get my data model and then try to find out whether or not the file exists and then have to check some names and things. I want to do that in one place, have that be one testable piece of code, and then use it somewhere else. So in this little line, I'm saying, hey, look, this recording exists if it's as an audio file. It returns and it exists from the file itself. And that returns true. And again, you're seeing the else operator didn't work because if any of that's null, either the file didn't come back, maybe the file system's not ready or something, or maybe it just doesn't exist, wasn't created, else operator takes over and says, nope, that's it, something was null, it's false, it doesn't exist, deal with it. That's pretty cool too. And then one little note here, we have this little equal sign. So what's cool in Kotlin as well is object or functions are first-class objects. They are, all of them are. So you're actually assigning to this function an object that has, oh goodness, what is it? It has no declared return type. And it's saying, hey, look, this function is just this little single expression. That's it. One little expression pops up there, that's it. So there's no return type. Sorry, I actually apologize. It's not the return type. It has to be a single expression, one line. So this is all one expression there. Right? And so that's it. That's essentially 2 lines of figuring out whether or not my data model exists as a file. That's pretty cool. So moving on from this, we're going to take a look at some lambdas. Hooray, I like lambdas, right? So lambdas, so I'll give you the kind of example they gave in the Kotlin, Try Kotlin website, because it was a little kind of messy. Like it kind of got a little too deep into what was going on, but it's actually great because it shows all of kind of what's going on with lambdas, right? So the first thing I'm going to point out is where is it? And that's it. That's the lambda. You'll notice there are 2 curly braces. All lambdas are surrounded by this guy. You're declaring that you essentially take in 2 parameters. And you're saying after this arrow that the body of this anonymous function, which is what a lambda is really, is return a dot length is less than b dot length, right? So there's a couple of things going on here. First of all, how does it know that A is a string and B is a string? Well, you don't really know that right yet. Not just yet, you do, right? Because that happens a little later. So now I have this max function. And the max function declares a type T, so regular old generic, right? This should be pretty familiar if you're familiar with Java. And what's happening is, in the method declaration, or the function declaration, you can see that I'm saying this value less takes in a function object that has two variables of type T that returns a Boolean. And so if you go back and look at that function, oh yeah, the Kotlin compiler is recognizing that I have an object here, and it's inferring the types of A and B as strings, and says, okay, yeah, that totally returns a Boolean because A.length is less than B.length. That returns a Boolean. Excellent. I can call that can be passed into the function. And so in the function, we have a variable, we're basically trying to find the max length of some strings. And we're iterating over it, and all we're really doing is saying, hey, look, just go call the function. That's all it is. If you're familiar with, with on-click listeners, all an anonymous function is a much smaller, cleaner, compact way to say, all I really care about is a little bit of code with a couple of parameters. I don't want to say, new view on-click listener and put an override statement with a couple other things in there. Just give me somebody that will call me back, right? That's all I'm really interested in. And so that's what lambdas really do for you. So now, again, this is kind of an esoteric example. I don't know about you guys. I don't personally find the longest string length in many apps, but what I do have is my own little project I'm working on, which totally sucks, but I am working on it. And there was a use case that I had that I actually thought, wow, actually this is pretty cool. So I will warn you first off and say that whether or not this is any kind of expected patterns in Kotlin, I couldn't tell you, but I can tell you some of the things you can do with things like lambdas, right? So there are two things I want to point out. I have a managed media player, right? It's a media player object, right? If you pass it a URI or a file object, will start playing the media, right? But the media player has tons of callbacks, lots and lots of them. It has callbacks for whether you've been paired, or whether or not the audio file's done playing, or the media file's done playing. Or if there's been an error at some time during some period, during whatever the heck you've been doing, just lots and lots of listeners, but you don't always need them. But sometimes you do, depending on if you want to have some information in the user interface. But it's a real big pain in patootie to try to get all those listeners from your nice little clean business logic layer all the way into your managed media player Android class that should just be doing its thing. So what I'm doing is I'm defining a class managed media player, and there are two nullable variables. And they're of types unprepared listener, uncompletion listener for the media player, and they start out as null. Now, in this block, I have an init, and when you create instances of classes, think of init as if you had wrote a little function in your class that in your own data class that just called an init during a constructor. That's what happens, right? Kotlin, at runtime, you'll have an instance created, all of its default variables and instances will be created for it, and then you'll have init called on you. This is sort of like if you're an iOS developer, maybe you've heard of init. Self-init and having to do with that whole instance thing. So anyways, I've got this lambda here. You can see that with the left and right curly braces. And what I'm doing is I'm setting a completion listener on the media player. And just like you saw the A and the B in the last example, here we have MP, which is just the default name for the media player. What I'm doing is say, hey look, set a listener on this, and if there happens to be something listening for completions, call it. And that's it. Right in the init in 3 lines, I've already hooked up any external listeners to my completion listener. But it can be a little more complex, right? You can say I want to listen for preparation. So the managed media player also has to deal with things like, hey, how long is the current duration of the audio? Have you actually prepared yourself, set everything in motion? And then at the end, you can say, hey, look, if there's a listener, go tell them about that. So Lambda is a nice, clean way to kind of put all your code in a little kind of really small readable place, but give you lots of little powerful items. So that's 3 kind of small features that are actually really powerful, right? Type nullability all dealt with in one little question mark and maybe a colon as well. We've dealt with extensions which let you get really kind of interesting static functions wherever you want in a single class or really a single Kotlin file, but not having to worry about whether or not you can call it from outside or not, whether wondering that static singleton has been initialized. It's all right there. And of course we have the lambdas, which are just really useful tools. But the biggest thing about this is, should you use it right now? I'll say that I want to use it, but I kind of have to answer some questions. And the first one I have to answer is, well, what kind of problems am I trying to solve? Okay, Kotlin's cool and all, but again, I'm in the senior position. I'm trying to figure out, the best move to make so I don't shoot myself in the foot, a month from now. what kind of problems are we trying to solve? Have I defined those as problems that are they data? Are they Android specific? Is it I'm trying to teach an intern or something and he needs to understand kind of what code's doing? Is it expressivity? Are you working with others, or will you be working on a team with someone else? Because if you are, it doesn't sound like a great team-like thing to do to go say, hey, here's a super cool project and it's actually written in 2 languages and Kotlin's one of them, go learn some koans and give it a shot. Not a great way to kind of intro someone to the team, but something to think about, right? But this one's a little bit more for yourself too, is are you going to be able to take the language and do something with it and maybe surpass the things you had in Java, right? It's cool, well and good to say, yeah, I want to Kotlin because they're doing a hot thing, but what are you going to get out of it as a developer? If what you have works right now, well, there's no real reason to change to it. You don't have to go take a week and refactor your entire project. If it works, it works. But if you think you're going to gain something out of it, do it, right? Because it actually is a great language. You've seen a couple examples here. And I think it all really boils down to that magic word intent, right? If Kotlin, if the really small samples you've seen, the tiny ones, have said, oh yeah, I really hate overrides and nullability and ifs and thens and all those different things. I like single line expressions. If it helps you get across the idea of your intent and not having to worry about, what framework you're using. Are you using this, injection framework like Dagger, or is it this other thing? If you can just write simple, clean, expressive code and talk to someone about it, then you've done almost all the hard work, right? Now you have to write the app itself. So Kotlin does that. At least it has done for me, has done it for me so far. And in really the end, that if it is a language that helps express your intent, then you should totally just use it. So yeah, that's my big talk on Kotlin, guys. So thank you very much. If there's any questions, I'll happily take some now. Anything you got? Take a picture.
The biggest pain in the butt I find about just native Android is whenever I want to do something on a separate thread, it's like async task, runnable, timer task, thread. Okay, so how there's 4 different options and it's all very long. How simple is it to do it in Kotlin, to do something on a separate thread?
Okay, so you're tackling something I'm a little less familiar with. Okay. But I can tell you some basics about it, right? Mm. So there's the new super cool hotness, which Kotlin is trying to go for, called coroutines. And coroutines are a really interesting take on how to do threading. The idea is I have some call sites in some function of mine, and I want that to be threaded. I want it to be asynchronous. So I'm going to write the code as if it's synchronous, but through the magic of coroutines with little dwarves doing something, the code executes asynchronously, and that is a matter of, I think, just clearing a couple compiler flags, or not compiler flags, function flags saying this is a coroutine and then executing it, right? And that's your asynchronicity. But that's not something that I'd recommend using, especially because it's brand new. I think it's actually still an alpha or a beta now. But in terms of raw threading, you kind of use, at least what I've done so far, is use the tools I have for the Android domain, right? Again, all of my experience is with Android. So if I'm doing threading, I'm going to use things like handlers, I'm going to use things like regular threads and starting them up. But what I am going to be able to do is use very simple class structures to make that threading happen, right? If I need to instantiate a handler thread and then get a hold of its looper and then actually post some things to it, maybe post some messages, I don't want to have to write 1,000 runnables and have to do that. I want to have maybe a little delegate class that I can call into. Kotlin has some really cool delegated properties and classes you can use. But I want to say make a very small data class that just has a handler that I could say, look, it's the same thing passed around. Maybe you want to make it a default object. But really, I think threading, your patterns, from what I've seen, don't change too much between the languages. So if you're doing something in threading like RxJava, which is going to be something coming up in our next talk, the tools Kotlin gives you make those threading patterns easier to deal with, right? You don't have to deal with all of the nonsense of constructing objects and dealing with all the verbosity. You can do the complex threading outside of the language. Mm-hmm. And hopefully that helps a little bit.
Definitely look it up. I'm sure you write less lines of code for sure.
You absolutely write fewer lines of code. Like I said, with there is no new runnable or new runnable override run with 3 extra curly braces. It's just a little lambda, pop it in there. Anything else? Awesome. Well, guys, thank you again for your time.